Good day, grade 10 students. Another day again for the lessons on Mathematics 10. And I'm your teacher Darwin. And for today's topic, I'll be discussing about the theorems related to chords, arcs, central angles, and inscribed angles. So, let's proceed. Okay, so before we start the proper lesson, let's have first the objectives for today's lesson. Okay, so the first one is for you to recall the definition of terms related to circles. Second, you need to prove theorem related to chords, arcs, central angles, and inscribed angles. Okay, so let's start with the first theorem. Theorem on central angle. It says here that the measure of the central angle is equal to the measure of its intercepted arc. So as shown in the example, we have the figure with a central angle of angle ABC and an arc of arc AC. So if we have the value of angle ABC, which is equal to 67 degrees, we will have the measurement of its intercepted arc as 67 also. Okay, so again, if the measurement of the central angle is 67, then also the intercepted arc is also 67. Because of the theorem, the measurement of the central angle is equal to the measurement of its intercepted arc. So that's it for the central angle theorem. Next, we have inscribed angles. So in this figure, we will have some example of inscribed angle and some that is not considered as an inscribed angle. Okay, before we explained the reason behind the figures. Let's have first define what is an inscribed angle. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords. When we say is on a circle, that means in the part of the circle, not in the middle, but in the edges of the circle. Okay, so first, for the first example, we have this is not an inscribed angle because it doesn't lie on the circle. Second, yes, it is an inscribed angle because its vertex lies on the circle. And third, this is not an inscribed angle because its vertex is in the origin of the circle. And this is a central angle. So this is not an inscribed angle. Next, for the fourth figure, this is an inscribed angle because it's lie on the circle. Okay, so those are some examples to consider on having inscribed angle. Okay, let's move with the theorem or the inscribed angle theorem. It says here that the measure of inscribed angle is 1/2 of its intercepted arc. So we have here the inscribed angle and second the intercepted arc. Again, the measure of inscribed angle is 1/2 of its intercepted arc. Okay, so in this figure, we are given a value of intercepted arc which measures 110 degrees. So that means we need to get its half to have our inscribed angle. So the half of 110 degrees is actually equal to 55 degrees. So here in the illustration, you can see that the measurement of the intercepted arc is 110 degrees and its inscribed angle is 55 degrees. That is the half of the measurement of intercepted arc. But in some case that we are given the value of inscribed angle, the technique on how to get the measurement of the intercepted arc is just multiply the measurement of inscribed angle by 2. So if we have the value of inscribed angle, which is equal to 55 degrees, we just multiply it by 2, and we will have the value of the intercepted arc, which is 110 degrees. And vice versa, if we are given the value of the intercepted arc, we need to get its half. So that is 55 degrees to get the value or the measurement of the inscribed angle. So that's the technique for getting the inscribed angle and also for the intercepted arc. So we have here some application. Find the value of x and y in the figure. Okay, so in this figure, we need to get the value of x, which is an inscribed angle. We have angle PTQ or angle x. So if we are given the value of or the measurement for its intercepted arc, which is 40 degrees, we just need to get its half. So we will have x is equal to 20 degrees. And for the y part, okay, so we are given the value of its inscribed angle, which is 50 degrees. So we need to multiply it by 2. So if we multiply it by 2, we will have the intercepted arc PQR, which measures 100 degrees. But in this figure, we are given the measurement for PQ as 40 degrees. So to complete the measurement of the intercepted arc of angle PSR, that is actually equal to 100 degrees. So if we have 40 degrees here, the remaining, which is 60 degrees, is the value of our y. Okay, so that's for the value of x and y in this figure. Another one, find the value of x and y in the figure. Okay, so we need to get the value of x here, angle QTR or angle x, and angle QPR or angle y. But if you can see in the figure, actually, the arc of these three given angles, also with QSR, is actually the same with the arc or the intercepted arc for angle QPR and angle QTR, or for angle Y and then angle X. Okay, so if we are given the measurement of angle QSR as 50 degrees, this is our inscribed angle. We just need to multiply it by 2 and we will have our measurement of for our intercepted arc. So that is equal actually to 100 degrees. So if we are given or if we have the measurement of the intercepted arc as 100 degrees, so the value of our y here is actually 50 because the half of the measurement of the intercepted arc is the measurement of our inscribed angle. So same value with angle QSR. So the measurement for our y or angle y is actually equal to 50, and same with the measurement of angle x because they share the same intercepted arc. Okay, so for x we have 50 and also with y we have 50 degrees also. Okay, so that's it for the inscribed angle theorem. Okay, so we also have some examples here for inscribed angle. An angle formed by a chord and a tangent can be considered as an inscribed angle. Okay, so this can actually be an example for inscribed angle. So we have a tangent line and then a chord. Okay, so this considered as example of inscribed angle. So same, if the measurement of angle P RQ is equal to 1/2 of the measurement of arc PR. Okay, so that's it. Let's move on with the interior angle theorem. Okay, so for this theorem, the measure of angle formed by the chords is equal to 1/2 the sum of the measurement of in the intercepted arcs. So we have two intercepted arcs here. We have arc AC and then arc DB. Okay, so this is our formula for this part. The measurement of angle 1 is equal to 1/2 the sum of the measurement of arc AC plus the measurement of arc BD. Okay, so this is our interior angle theorem. Again, to get the measurement of angle 1, we get the half of the measurement of arc AC plus the measurement of arc BD. Okay, so for some example, we have here. Okay, so first, let's solve for the value of x. Okay, so again, in the formula, for the measurement of x, we just need to get the half of the sum of two intercepted arc of x. So the measurement of two intercepted arc, which are the arc AC and then arc BD here. So for arc AC, the measurement of arc AC is equal to 91, and then the measurement of arc BD is equal to 85. So if we get the sum of these two arcs, we will have x as 88. So 91 plus 85 is 176. And if we get the half of 176, we have x is equal to 88 degrees. Okay, so next, for y, how can we solve for y? Okay, so if we apply actually the straight angle theorem here, or the application of straight angle, if the measurement of this angle x is 88, to complete this, or to solve for the value of y, or the measurement of y, we subtract 180 by 88, and we will have y is equal to 92. So the measurement of two unknown angles, for angle x that is equal to 88, and then for angle y, that is equal to 92 degrees. Okay, so that's for the interior angle theorem. Next, we have the exterior angle theorem. For the exterior angle theorem, the measure of angle formed is equal to 1/2 the difference of the measure of the intercepted arcs. Okay, now for the exterior angle, actually we are going to get the half of the difference of the measure of the intercepted arcs. Okay, and this is our formula. To solve for the measurement of angle 1, we get the half of the difference of two intercepted arcs. We have here the first arc and then the second arc. Okay, so for some example, we are given the measurement. We need to find the measurement of angle C. So for the first arc, we have arc BA, which is equal to 95 degrees. And for the second arc, we have that is also arc BA, that is equal to 265 degrees. Okay, so we need to get the difference between 265 and 95. So 265 minus 95 is actually equal to 170 degrees. And we need to get its half to have our exterior angle, or to solve the measurement of our exterior angle. So if we are given the difference between 265 and 95 as equal to 170, we get its half. So we will have 85 degrees as the measurement of angle C, or our exterior angle. So for this example, the measurement of angle C is equal to 85 degrees. That's it for the application for exterior angle theorem. Okay, so we have there, and that's all for the theorems on chords, central angles, inscribed angle, and then intercepted arcs. So thank you for watching.